So if a function u of f of x is continuous at a point x equal to a, and the function y equal to g of u is continuous at the point u equal to f of a, that means it is like this. This is a function y is equal to g of f of x. Now f of x is continuous at x equal to x equal to a, and g of x has to be continuous. See, for this function to be continuous here, for this function to be continuous, f of x must be continuous at x equal to a, and g of x must be continuous at f of a. All right, when x goes to a, so g should be continuous at f of a. Then we say function is continuous. For example, let us try to take a discontinuous function. So let us take a sine of tan x. Sine of tan x. This is a function. Now, in fact, I'll do like this. Sine of pi by 4 tan x. All right. Now, at x equal to pi by 4, at x equal to pi by 4, that is at 45 degree, tan x is continuous. Tan x is equal to 1. It is a continuous function. So this will be, so tan x is continuous. So, and in fact, tan pi by 4 will be equal to 1. All right. So therefore, this function f of x is sine of pi by 4 tan x will be continuous at x equal to pi by 4, because what? Because sine is continuous. Of course, sine is continuous for all, but we will discuss this. Sine is continuous at pi by 4 tan pi by 4, which is pi by 4. Okay. So the answer will, so function value will be 1 upon root 2. So this function f is continuous at x equal to pi by 4. All right. Now consider this case at x equal to pi by 2. At x equal to pi by 2, what happens? We all know how the tan function looks like. So it is 1.57, something close. So something like this. This is the value of, this is pi by 2 here. Now, as x approaches pi by 2 from the left, tan x approaches plus infinity. But when x approaches pi by 2 from the right, tan x approaches minus infinity. So function is discontinuous and function is not defined at that point. So at x equal to 2, at x equal to pi by 2, tan x is discontinuous. Therefore, f of x is equal to sine of pi by 4 tan x will also be discontinuous. In fact, it is not even defined, you can say. Same we can do in this way. Just I reverse the example. Let's say f of x is tan of pi by 2 sine x at x equal to pi by 2. At x equal to pi by 2, sine x will be a continuous function. Sine x is a continuous, throughout continuous function. So sine x is defined. However, tan of pi by 2 sine x at x equal to pi by 2. So it will be pi by 2 into 1. So tan will not be continuous. What is the answer for this? Will it be continuous or not?
Discontinuous, no, sir.
Why? What will be the left hand limit and right hand limit? Tell me. I'll define tan x like the function like this. Tan of pi by 2 sine x for x from 0 to 2 pi we will take. Okay, so 0 to 2 pi or 0 to pi. Except pi by 2. X not equal to pi by 2. 0 to pi. For x equal to pi by 2, let's say we say it is 1. Now you tell. What is the left hand limit and right hand limit of this function? At pi by 2.
Plus infinity, right hand limit is minus infinity.
Okay, left hand limit x tends to pi by 2 minus tan of pi by 2 sine x. This will be tan of pi by 2 into 1. Okay, pi by 2 into 1. Now this 1, this number will be greater than 1 or less than 1?
Less than 1.
So this product will be slightly less than pi by 2. So slightly less than pi by 2, you get plus infinity. Now let us look at right hand limit. Limit x tends to pi by 2 plus tan pi by 2 sine x, which is tan of pi by 2 into 1. What? Plus or minus? Value of sine x at pi by 2 plus. It will be 1 plus or 1 minus?
Minus.
Good. Because sine will always be less than 1. So again, this will be plus infinity. Both limits are tending to infinity. But the function value here is defined as 1. So therefore, the function will be discontinuous. And one more thing, you cannot define at exactly x equal to pi by 2, sine x will be exactly equal to 1. So pi by 2 into 1, this will be exactly equal to pi by 2. So tan pi by 2 is undefined. That's why we have to define like this. So this is about composite continuity. You have to see the function within should be continuous and the outer function should be continuous at the function value within. All right. So both. So in the previous case, what we saw was the inside function itself is discontinuous at x equal to pi by 2. In the next example, what we discussed is inside function is continuous throughout, but the outer function is discontinuous. So these you have to be careful in composite functions. We just need to be little thoughtful.